This video covers review 19 over simplifying radicals. Now, all of these problems on the review, I would recommend typing into the calculator beforehand. So problem 1, I would type in the square root of 50, and I see that it doesn't work nicely, so I need to work it by hand. There will be some that I type in because I know that they're going to work nicely. There will be some I don't type in because I've already worked the problems. But every single one I would recommend typing in because some of them are very quick if you type it into the calculator and will take a lot longer if you don't. Now problem 1 we just typed in and it didn't work nicely, so I need to come up with some factors. 50 can be multiplied by 10 and 5. 10 times 5 is 50. 5 cannot be broken down further, but 10 is 5 and 2. So we have 2, 5, and 5 as my factors. Any pairs that I take out are listed outside of my square root. And any letters or numbers that I have to keep inside stay inside my square root. So remember that you're always looking for the most simplified version. Anything that goes outside means that it had a pair. Anything that stays inside means that it didn't have anything to come out of this square root. So problem 2, I type into my calculator and it doesn't work nicely. So 96 can be multiplied by 6 and 16. 6 is 2 and 3. 16 is 4 and 4. Now 4 can be broken down further into 2, 2, 2, 2, so you can break it down further. However, once you have a pair, you can also stop because you're going to break them down and then have to multiply them back. So I'm going to bring out a 4. 2 and 3 are staying inside the square root and are multiplied together to make 6. Now I originally had a 2 outside the square root of 96 as well. So I take that 2 and multiply it by whatever I brought out. I brought out a 4, so 2 times 4 is 8, and the inside square root does not change whatsoever. Problem 3, I try to type in the square root of 98, and it doesn't work nicely, so I need to break it up. 98 is 2 and 49. 49 is 7 and 7. So I can take out a pair of 7s and leave the 2 under the square root. The square root of a squared, we take that exponent and divide by 2, and we get 1. That exponent is even, so all of the exponents will come out. B, 9 divided by 2 is 4.5. So 4 go outside, 0.5 means there's 1 left inside. So simplifying the square root of 98a squared b9, I have 7 on the outside, a1 on the outside, and b4 on the outside. Inside the square root, I have 2 and b. I have done nothing yet with the 5a3, b2. So I have simplified everything in green was me simplifying this square root. 7a1b4 square root of 2b is the simplified version of this. Also, if I haven't said it yet already, remember that after you've plugged them in and you see that the square root of 98 doesn't work nicely, when you simplify it to 7 square root 2, you can check all of your answers to make sure you have the same ugly decimal or the same matching decimal as what you started with and what you ended with. Please keep in mind that any multiple choice answers you can compare, but some of them say which is the most simplified version, and the most simplified means that there's probably more than one answer that is correct that has the same decimal, but only one of them is the most simplified. From here, I multiply the big number, so 5 times 7 is 35. And add the little exponents. So a to the 3 plus 1 is 4. B to the 2 plus 4 is 6. And then the square root of 2b stays exactly the same because I have nothing else under the square root to change. Remember that for all of these problems, anything you bring outside, anything that is already outside, anything that stays inside, you multiply unless you see a plus or minus sign in your problem. So we do lots of multiplication with this unit. Now the square root of 25 over 100 should work nicely because the square root of 25 is nice and the square root of 100 is nice. Remember, if you do alpha y equals, it will give it to you as a fraction. So the square root of 25 over 100 simplified to 1/2. Now I just have to do the square roots of my exponents. So x to the 6 divided by 2 is 3, and 6 is even, so it completely comes out of the square root. Y to the 12 divided by 2 is 6. 12 is also even, so it also comes out of the square root. So I have the number 1/2. My x started in the top, so I simplify it and leave it in the top. My y started in the bottom, so my simplified ends in the bottom. Problem 5, we have 2 over the square root of 6. The square root of 6 is on the outside of, on the inside of the square root. 2 is on the outside because we have one outside and one inside. I cannot combine these whatsoever, which means the only thing I can try is to simplify the square root of 6. When I plug it into my calculator, it does not simplify nicely. So I have to multiply the top and the bottom by the square root of 6. Remember that math is all about equality. So whatever you do to the top, you have to do to the bottom. Otherwise, it changes the value of the problem. On the top, 2 times the square root of 6. 2 is on the outside. The square root of 6 is on the inside. I can't combine them whatsoever, so I simply rewrite them. On the bottom, a square root times itself cancels out the square root, and you just have the number. So on the top, I have 2 square root 6. On the bottom, I just have 6. Now, 2 over 6 will simplify to a fraction, but a smaller fraction. So 2 over 6, they are both on the outside of my square root, so I can simplify them. So my answer is the square root of 6 over 3 or 1 square root 6 over 3. Those mean the same thing. Remember that the square root of 6 started on the top, so it has to stay on the top. And remember, the whole point of doing this is to get rid of the square root on the bottom. If you have a square root on the bottom, that is not okay, and you have to take whatever steps it takes, other than non-math things, to get rid of the square root. To get rid of the square root, we multiply it on the bottom, so the square root will cancel. Whatever we do to the bottom, we have to do to the top. The top, we follow our normal multiplication rules, and then do the actual dividing at the end. Problem 6, we have the square root of 3 times the square root of 18. Both of these are inside the square root, so we will put them together to get the square root of 54. Now, obviously, 54 doesn't work out nicely. If you typed this in from the beginning, you would have seen if it worked nice or not. 54, we obviously know is 3 times 18 because we just did that. 18 is 3 and 6. 6 is 2 and 3. So I have 2, 3, 3, 3 as my factors. I can take out a set of 3's, and I have a 2 and a 3 left inside for a total of 6 left under the square roots. So remember, with multiplication, you do the multiplication first, then simplify at the end. Now, problem 7 was one of the most missed ones on the quiz. This problem, we type in the square roots and it doesn't work nicely. However, what most people didn't think to do is see if you can do the multiplication inside without the square roots. So when I type in 3/8 times 7/2, that simplifies to the square root. I haven't done anything to get rid of the square root. I've simply multiplied what's under the square roots without the square root because the square root didn't work nicely. Now with this problem, 21 over 16 is the most simplified. The fraction wouldn't tell us what it was from the calculator if it wasn't the most simplified. I have a square root on the bottom, so I'm going to try to break it up to see if I can simplify this. The square root of 21 does not simplify, but the square root of 16 is 4, so I replace the square root of 16 with 4. Now on the bottom, I no longer have a square root, and so I'm done with this problem because there's nothing inside the square roots that I can simplify. There's nothing outside the square roots that I can simplify. The next couple of problems can be simplified inside the calculator or with the calculator. So problem 8, I'm going to type it in exactly like I see. 4 square root 2 times 5 square root 8. And I get the answer 80 because I used my calculator. So again, on 1 through 8, I would check all of these in the calculator. I've already done it, so for the sake of time, I'm not doing it on every single problem so that you can see which ones need to be worked out. But if it says all of these, you should type it into the calculator because some of them work out real nice and quick. Problem 9. I don't know why I said problem 2. Problem 9, we have square roots of 6 and square roots of 6. The square root of 6 cannot be simplified, and so there's nothing I can do to simplify the square root. However, I can simplify this problem. Because they're both the square root of 6, all I need to do is do what the numbers in front say. So 2 minus 9 is how many total square roots of 6 I have. 2 minus 9 is -7, and my square roots of 6 stay the same. So when you're adding or subtracting, the only time you add or subtract is when you see a plus or minus sign in your problem. Otherwise, we're multiplying. If you see a plus or minus sign, make sure your square roots are the same. If they are, combine the numbers in front and keep the square root the same. Problem 10, we put it in the calculator and it doesn't work out nicely. So the next thing I'm going to try is to simplify these personally, like the top and the bottom. The square root of 5 does not work nicely, but the square root of 49 is 7. I no longer have a square root in the bottom, and I have an inside the square root and an outside that I can't combine, so therefore I'm done with this problem. So remember, the big thing with division is to get rid of those fractions. You can't have not necessarily to get rid of the fraction, I apologize, to get rid of the square root in the denominator of my fraction. Okay. Now problem 11, especially with multiplication, if you guys remember on the multiplication assignment, that was the one where we had the most that could go into the calculator. So I'm going to try that. 3 square root 5 times 4 square root 5. And this one also works out really nicely in the calculator. It's just 60. Problem 12, I'm going to try that one in the calculator because it's another multiplication one. This one you need to be very careful to type it in exactly how you see it. We have parentheses, the square root of 13, close parentheses, then the squared. So I make sure I type it in exactly the same. Remember that when you're in the square root, to get out from under it, you just click the right arrow and then keep typing. When I click enter, this one can also be done in my calculator, and I get 13. Problem 13 is an adding or subtracting one. This one is an adding. When I type this in, it does not work nicely in my calculator, so I have to break down the square roots by hand if possible. 45 is 5 times 9. 9 is 3 and 3. So I'm going to take out a set of 3's, and 5 stays inside this square root. I had this 3 that was originally in front of my problem, so remember, everything that we do, we multiply until we see the plus sign. So 3 times 3 is 9 square roots of 5. Now simplify the square root of 36, and remember these are different parts to the problem, so we don't combine them till the very end. The square root of 36 is 6, so we replace the square root of 36 with the number 6. Remember, if you type in a number into the square root, such as the square root of 36, and you get an answer, this answer does not have a square root because we got rid of this square root by finding the square root. So the square root of 36 is just replaced with this number. I don't have a square root in my calculator, so I don't keep the 6 under the square root. Now 7 times 6 is 42. On the left side, we have the square root of 5. On the right side, we don't have any square roots, so I can't do anything further to this problem because I don't have the same square roots. Problem 14, we have 30 and 6 both inside of the square root, so that could be rewritten like this. 30 divided by 6 is 5. I no longer have a fraction, which means that I am done with this problem. It's really like this, and 1 is not under the square root, and because I don't have a square root in my denominator, that problem is finished. Problem 15, I have a 22 outside the square root and a 2 inside the square root, which means there's nothing I can do to combine them. I type in the square root of 2 in my calculator and it doesn't work nicely. So on the bottom, I have to get rid of the square root of 2, so I'm going to multiply it by itself. Whatever I do to the bottom, I must do to the top as well. On the top, 22 is outside of the square root, 2 is under the square root. I cannot combine them, so I simply rewrite them. And then the square root of 2 times the square root of 2 is 2 without the square root. My last step is to see if I have anything outside that can combine or divide, and I do. 22 and 2 are both outside of the square root, so I type in my calculator 22 divided by 2, and it tells me it's 11. I've done nothing to change the square root of 2, so I simply rewrite that in my problem. Problem 16 is another multiplication problem, so I would put this into my calculator first. I've already tried it and it doesn't work out nicely. So whatever is outside gets multiplied with outside, and inside gets multiplied with inside. So outside, negative 5 times negative 3 is a positive 15. Inside, 8 times 5 is 40. From here, I break up the square root of 40. 40, as we obviously just did, is 8 times 5. 8 is 2 and 4. 4 is 2 and 2. So I have a set of 2's that can go outside. And inside the square root, I have a 2 and a 5 for a total of 10. I also had this 15 that was originally outside. Remember, anything outside you multiply together. So 15 times 2 is 30, and the square root of 10 stays the same. So with multiplication, if you try it and it does not work in your calculator, outside multiplies with outside, inside multiplies with inside. And then from there, if you can simplify the inside, do it. Whatever you bring outside multiplies with whatever was already outside. And then whatever's inside just stays inside. Now, problem 17, we have an adding or subtracting, so we have to simplify first. The square root of 63 can be simplified into 3 and 21. 21 is 3 and 7, so I can take out a pair of 3's. I will leave in the 7. If you haven't noticed, every time you plug in a square root and it doesn't end up nicely, you should always end up with a number left under the square root. There's no way that you can plug this into the calculator and not get a whole number but end up with nothing under the square root at the end. Now 4 and 3 were already outside of the square root, so we multiply them together. And then we do the next part. So 32 is 4 and 8. 8 is 4 and 2. I have a group of 4, so I can stop. Remember, you can keep going if you want, but it doesn't super help you because you're going to break them down and then put them back together. 3 times 4 is 12, and I have the square root of 2. Please notice I brought that negative sign down and put it here already. Some people are skipping that step, and it's going to mess you up if you have like square roots. Now, I have the square root of 7, the square root of 2. Those are not the same square roots, so there's nothing further I can do to this problem. But it would be wrong if you did not simplify this problem at all. Problem 18, we have 2 and 7, both inside of the square roots. One thing that you can do is see if you can simplify the fraction at all, and we can't. We can break this up into the square root of 2 times this, or divided by the square root of 7. When you try to take both of the square roots, it does not work out nicely. There's nothing that you can do to simplify the square root of 2, and there's nothing you can do to simplify the square root of 7. I have to get rid of the square root in the bottom, so to get rid of it, I'm going to multiply it by that same number because the square roots will cancel. Whatever I do to the bottom, I must do to the top. On the top, the square root of 2 and the square root of 7 are both inside the square roots, so we multiply. 2 times 7 is 14. On the bottom, my square roots cancel, and I have 7. Now the square root of 14 is under the square root. 7 is outside of the square root. There's nothing I can do to simplify them because they're not in the same positions. So I'm done with that problem. Problem 19. 6 and 12 are both under the square roots, so we multiply them to get 72. We would have already plugged this into the calculator and seen that it does not work, so I must simplify by hand. Obviously, we just did 6 times 12 to get 72, so I can undo it with 6 and 12. 6 is 2 and 3, 12 is 3 and 4, 4 is 2 and 2. So we have 2, 2, 2, 3, and 3. So a set of 2's and a set of 3's can come outside to make 6. And then a 2 will stay inside. So remember, whatever you bring out multiplies without. Whatever stays in multiplies and stays in. The only time you add or subtract is if you see a plus or minus sign in your problem. This one does not have a plus or minus sign. We did not add anywhere in this problem. Whatever we broke up, we divided. Once we take our factors out, we multiply them. That is the only thing you're doing on these problems. Adding is only for problems like this. Now, with this, adding or subtracting, you have to have the same square roots. These cannot be simplified. The square root of 5 can't be simplified. The square root of 2 can't be simplified. So I'm ready to combine like I see it. Some people, it helps to put a 1 if you don't see a number in front because they are messing up by not adding that 1. So in front of the square roots of 5, I have 3 plus 1. In front of the square roots of 2, I have 3 and 6 minus 3. So I'm combining my like terms. In this case, my terms are square roots. So 3 plus 1 is 4 square roots of 5. 6 minus 3 is 3 square roots of 2. For my answer, I just put it together. I have 4 square roots of 5 and a positive 3 square roots of 2. Problem 21 is a multiplication problem. Negative 3 is the only thing outside. 6 and 18 multiply to the inside to make 108. We just said 6 and 18 multiply to 108. And again, I would have put this in my calculator. I see that it doesn't work, so I have to break it back up. 18 is 6 and 3. I have a pair of 6's, and I can't take 3 down anymore. So I had a negative 3 out front. I'm bringing out a 6, and I'm leaving in a 3. Negative 3 times 6 is negative 18. The square root of 3 stays as the square root of 3. So again, multiply inside with inside, simplify by hand. Anything you take out multiplies out. Anything you leave in multiplies in. Problem 22, 24 and 2 are both inside the square root, so they could also be rewritten like this. I would have tried this in my calculator and seen that it didn't work, so I'm trying to see how can I get rid of the 2 on the bottom. 24 and 2 are both inside, so I can divide them as I see it, and that would make the square root of 12. And then the square root of 12, I can simplify. I get 2, 2, and 3, so I can take out a 2 and leave in a 3. So this would be 2 square root 3. So again, if they're both under the square root, sometimes, not all the time, because we've seen they don't always work like that, but if they're both under this square root and you can divide them, because now I just have to simplify that by hand and I'm done. Save myself a lot of time doing that. Problem 23 is an adding or subtracting, so this is one of the only ones that I will add or subtract. First, I got to simplify my square roots. The square root of 2 cannot be simplified, so I simply rewrite this. As you guys have seen, I rewrite mine on the very bottom to make sure that I don't forget it and don't lose it somewhere in my problem. 72 is 8 and 9. 8 is 2 and 4. 4 is 2 and 2. 9 is 3 and 3. So 72, I can take out a 2 and a 3 to make 6. and I leave in this 2 under the square root. I had a negative 6 originally in front. I multiply these. Negative 6 times 6 is negative 36. And the square root of 2 is rewritten. Remember, even though these problems have minuses and pluses, we don't add to the very end. So even here, we're still simplifying. We take out the 2, we take out the 3, we multiply it together. There was already a negative 6 outside. We brought out a 6, we multiply it together. We don't add or subtract until we're at the final stage. So that's the only time pretty much on the entire test that you add or subtract is in the final stage after you've done all this, but you have pluses and minuses in your problem. The square root of 50 is 5 and 10. 10 is 5 and 2. I can take out a set of 5s, and I leave in a 2. There was already an 8 out front, so 8 times 5 is 40 square roots of 2. Now that I've simplified all 3 terms, I'm ready to add. If they have the same square roots, then I add the numbers in front. These have the same square roots, so I add everything that's in front. So I do 4 minus 36 plus 40. This is something you can quickly do in your calculator. 4 minus 36 plus 40, and I'm just doing exactly what I see in front of the numbers for a total of 8 square roots of 2. Problem 24. Again, I would put all of these in the calculator from the start. This one is one that works out nicely, so that's why I'm doing it. Square root, or the squared of 4 square roots of 6 is 96. And again, that happens in the calculator. So it will pay off if you type all of these into the calculator first before simplifying things. You can simplify it if you want, but that's going to take a lot of time, and you don't have a ton of time to waste on this test. Problem 25, we type in 363 and it doesn't work out nicely. I can see it ends in a 3, so it might be divisible by 3, and it's 3 times 121. 121 is 11 times 11. So my 11s go outside. My square root of 3 will stay inside because 3 does not have any reason to get out of the square root. When you have letters, we divide the exponent by 2 because we're trying to see how many pairs of 2 we can make. We can make 1.5, so we take 1 out. 0.5 means leave 1 under. The square root of y squared is 2 divided by 2, and we get 1. The square root of z will stay the square root of z because we only have 1 divided by 2 and we don't have enough to make a pair. So I put my answer back together. I have 11 outside of the square root for my numbers, x outside for my x, y, and nothing for z. Under the square root, I have 3, an x, and a z. That's a y. And a z. So for these, it's easiest if you break it up into numbers and each letter separately and then put it back together at the end. This is one of the only ones where I will add or subtract. The square root of 48 and the square root of 12 can both be simplified. 48 is 4 and 12. 4 is 2 and 2. 12 is 2 and 6. 6 is 2 and 3. So I have 2, 2, 2, 2, 3. I can take out 2 sets of 2's to make 4 and a 3 to make 3. 12 simplifies into 2 and 6, 2 and 3. So bring down the negative, take out a 2, leave in a 3. These both have the exact same square root, so 4 minus 2 are my numbers in front, and that will tell me my total square roots of 3. 4 minus 2 is 2. Please notice again that I did not break this up until the very end. I did not do the minus until the very end. I took 48, broke it up, simplified. I took 12, simplified. Then I looked at how many square roots of each type I have, and I break them up and I do what the numbers in front say. Problem 27 is another one where you would immediately type it in and see an answer in the calculator. So I type it in exactly like I see it. The square root of 24 minus 3 times the square root of 225. And you get negative 27 for your answer from the calculator. 28 is another one that I would try to type in the calculator exactly like I see it. And I can see that the answer is very quickly 2/3 from the calculator. So please, as you can see, like maybe about 1/3 or 1/4 of these we've been able to do in the calculator. Please don't be afraid to use that calculator tomorrow. You can't just use it to compare all of your answers because not all of them are multiple choice, but the ones that are multiple choice, it can help you, and the ones that are quickly done in the calculator, it will help you. This problem is one of the longest, hardest problems that we have. The square root of 168 does not work out nicely, so we have to break it up. We can break it up into 4 and 42. 42 is 6 and 7. 4 is 2 and 2. 6 is 2 and 3. So we have 2, 2, 2, 3, 7. So we can take out a set of 2's. Inside we have 2, 3, and 7 for 42. I know it looks weird because 42 we feel like we should be able to take out more, but we can't because we can only take out pairs. For the m's, 3 divided by 2 is 1.5. So 1 goes outside, 0.5 means 1 stays inside. For the n's, 2 divided by 2 is 1, and it goes outside completely. So when I simplify this, I have 2 outside, m outside, n outside. Under the square root, I have 42 and m. Now, this in green, again, is just the simplified version of the square root. I still have this 3m squared n out front. Anything that's outside gets multiplied to outside, so 3 and 2 are multiplied like normal numbers to make 6. M's we add, so m squared and m is 3, because we have 2 plus invisible 1. And then n plus n is n squared, because we're just adding the exponents. 42m stays under the square root. So again, in green, we just simplified the square root, and then we multiplied to the 3m squared n that was already out front. When you multiply big numbers like normal, you add the exponents for the letters. 30 is another problem that you would try to type into the calculator and it wouldn't work nicely. Also, just a quick note on 29, you could type in the 3 square root 168, but you cannot type the letters into the calculator, so you would just type the numbers to see if the numbers would simplify. You have to simplify letters by hand. So 30, we would type it in and it wouldn't work, so what I'm going to do is see, can I simplify the fractions at least, or at least multiply the fractions, do the under part, and keep it under the square root. So 5/4 times 8/9 is 10 over 9, and again, I've done nothing to get rid of the square root, so I leave it under the square root. Now I can also break it up into the square root of the top and the square root of the bottom. The square root of 10 isn't a nice number, but the square root of 9 is 3. I no longer have a square root in the denominator, and I don't have outside to simplify with outside, so that is my answer. Okay. The last little bit of the review is review from old problems. So write the equation of a line in point slope form that has a slope of 6 and contains the point -3, 7. Point slope form is y minus y1, mx minus x1. So my slope is my m. So I replace m. And then my point is 7 and -3. Notice that minus minus on my x's is really a plus, but this was your x1 and your y1. So all you're doing is looking at point slope form on your formula chart and plugging this in exactly like you see it. Y minus y1 equals mx minus x1. My m stands for slope. Slope is 6, so I replace m with 6. My point is x and y, so y goes first, x goes second, and remember they are the opposites of whatever you see. So 7 becomes a -7, -3, and my final answer is a +3. Problem 32, they want me to write the equation of a line through 2 points. So for that, I will use stat edit. So I go stat edit and enter my points. I have 1 and 3, -8 and 0. Please remember that you have to type the points in like you see them. 1 needs to go with -8, 3 needs to go with 0. I click Stat Calc 4, and my equation is for x minus 12. Problem 33 wants something that is perpendicular to this equation. So perpendicular would have the slope of -1/3. Again, I have a point and a slope, so I will plug in a point slope. Y minus y equals m x minus x. And again, my signs here change, so this becomes a plus and this becomes a minus. To solve, you would distribute -1/3 to x and -1/3 to 9. And then solve for y by adding 9 to both sides. So y is -1/3 x plus 6. Problem 34 asks for the x-intercept of 2x minus 4y equals 16. Remember, x-intercept means that y is 0, so we can plug in 0 for y and solve. If it's 0, it means this part will not matter, so 2x equals 16. Divide by 2, and x would equal 8, so that would be the point 8, 0. Alternatively, you can solve for y and plug it into your calculator to find it, but the easiest thing to do is just ignore the y or plug in 0 for y, which means your y cancels, and just solve for x. 35 is asking for a rate of change for special functions. The function y equals 0 has a y in it, which makes it a hoi. The O in hoi means your slope or rate of change is 0. X equals -3 makes it a vux. The U in vux means that it is undefined. So make sure you know the difference between those. And the equation of a line that is parallel to 2/3 x minus 5 and goes through the point -3, 2. Parallel means it's going to keep the same slope, so my m is still going to be 2/3. I'm going to plug into point slope, so y minus 2 equals my slope x plus 3. Again, remember your signs change when you plug in. And then I distribute, because the ones on my test want us to distribute and solve to put it in slope intercept. So 2/3 times x, 2/3 times 3. And then we add 2 to the numbers on both sides. So my final answer is 2/3 x plus 4.